So for today, we'll be talking about motion curves. That is basically the continuation of rectilinear motion as part of dynamics of rigid bodies. I'll share my screen. So this is still dynamics of rigid bodies. We are in our module 3. It's part of dynamics, which is kinematics. Again, dynamics is divided into two parts, and that is kinetics and kinematics. For kinetics, we are just concerned about the forces or torque that is causing the motion of an object. While kinematics, we are concerned about the geometry of motion, or how the object behaves in its motion. So this is motion curves as part of our, we call this rectilinear motion. For this unit, the following are our desired learning outcomes. First is to apply the principles of integration and differentiation of kinematic differential equations. I believe that you are done with your differential calculus and integral calculus, so this should be just a review and an application of the integral and differential calculus to motion curves. And the next topic learning outcomes would be to draw the motion curves of kinematic equations in using integration and motion curve drawing using the area method. So what are motion curves? It is often useful to utilize pictorial representation of kinematics using graphs, especially when the position of an object can be described by a differential equation of a curve. Note that in mathematics, a line is considered a first degree curve. So habang nag-i-increase yung curvature niya, nag-i-increase din yung degree ng curve. So parabola has a 2-degree curve and it increases to its degree. First degree kapag slanting yung line natin. Kapag wala naman siyang slope, ibig sabihin 0 degree siya. Or the degree is 0. So for kinematics, we basically have three quantities that are concerned with. The first one is position, velocity, and acceleration. Now, if you were given this kinematical differential equations, meaning the position is in terms of time, velocity is in terms of time, and acceleration is in terms of time, we can find the other quantities using only one of these quantities. If you're given, for example, the position vector or the position kinematical differential equation, you can find the equation of the velocity using the process of differentiation. So from position equation, you can find the velocity equation using differentiation, and in turn, again, by differentiating, you can also find your acceleration equation. If, for example, you are given the acceleration equation, if you want to find the velocity and position equation, what you will do is just the reverse of differentiation, and that is integration. So basically, this topic will revolve around differential calculus and area method later on. So let's start with motion with constant velocity. From our discussion or from the video that I have made regarding rectilinear motion, we basically have three types of rectilinear motion. Can someone enumerate the three types of rectilinear motion? Sinong makaka-differentiate nun or enumerate the three types of rectilinear motion? Mr. Gagarin, ikaw na lang. Ano again? 3 types of rectilinear motion.
Projectile.
Rectilinear ba yung projectile?
Ay, straight line, sir.
Straight line naman talaga ang rectilinear. Ano yung types niya? Mr. Javier. What are the 3 types of rectilinear motion? If you have no idea, sabihin nyo.
Uniform rectilinear motion.
Okay.
Uniformly accelerated rectilinear motion. Rectilinear movement with non-uniform acceleration.
Okay, those are the 3 types of your rectilinear motion. Pag sinabi nating uniform rectilinear motion, ibig sabihin, those are kinds of motion in a straight line with constant velocity. Yun yung nasa screen natin. Motion with constant velocity. Uniform rectilinear motion. Ibig sabihin nun, you are traveling equal distances at equal interval of time. There is no acceleration in this case because we have your constant velocity. Ibig sabihin, your initial velocity at any given time, time start, and your final velocity at the end of your time interval should always be equal. Constant nga yung velocity niya. It is not changing, meaning there is no acceleration. Tama ba? Okay. The next one would be uniformly accelerated. Ibig sabihin ng uniformly accelerated, there is a constant change in the velocity. Yung una natin ay constant velocity. Yung second naman is constant change in velocity of our motion. For rectilinear motion in a straight line, of course. Rectilinear nga. So, dapat straight line talaga yung path niya. And in that case, you are covering unequal distances. And the change in your velocity is equal. For example, ang acceleration mo ay 2 meters per second. And you have an initial velocity na 0 meters per second. After 1 second, ang final velocity mo na ay 2 meters per second. After another second, magiging 4 meters per second. And after another second, magiging 6 meters per second. Nag-i-increase nga siya ng 2 meters per second squared. Yun yung acceleration. That is why it can also be read as 2 meters per second per second. Ibig sabihin, it is increasing 2 meters per second per second. That is acceleration. Uniformly accelerated rectilinear motion. Now, that type of motion can also be taken as decrease. If your acceleration is increasing, yung, the decrease of our velocity from initial velocity of greater value or greater magnitude to a velocity of lesser magnitude, ibig sabihin nun, we are decreasing in velocity. There is a constant decrease in the velocity, meaning that is called deceleration. But still, it is still part of your second. Nawala ba?
Yes, sir.
Okay. Let's continue. Meron na. Okay. So, yung uniformly accelerated rectilinear motion, pwede siyang increase or decrease. Pag decrease siya, and that would be uniformly decelerated. Basically, same lang yung concept. Equal pa rin yung increase or decrease of our velocity. because acceleration is defined as the change in velocity with respect to time. Okay? So, pag deceleration siya, yung initial velocity mo, that should be greater than the final velocity. For example, if you are driving a car, ang initial velocity mo, kunwari ay 20 kilometers per hour, and if you are going to a full stop with constant change or constant decrease, syempre, from moving to stopping, di ba? Syempre, mag-decrease yung velocity natin. So, that is an example of deceleration. Constant yung increase. Although, mahirap i-achieve ang constant increase or decrease of velocity in actual, what do you call this? Actual scenarios. Pero, that is the second case. So, for the third case, that is, ano ulit yun, Mr. Gagarin? Movement?
Rectilinear movement with non-uniform acceleration.
Okay, rectilinear movement with non-uniform acceleration. Ibig sabihin na nun, hindi nagpabago-bago yung change niya. Kung yung sa second case natin, we are having a constant change, yung last naman natin, irregular lang yung change niya. For example, start ka sa 0 meters per second. Yung next na velocity mo ay 2 meters per second. The next velocity is 3 meters per second. So, hindi constant yung increase ng ating velocity or hindi constant yung decrease. So, yun yung variable. Varying ang value ng velocity. Is it clear? Clear ba? Okay. By the way, how do you produce rectilinear motion in terms of its center of gravity? Anyone?
Something constant speed, sir.
Constant speed? No, that is just a part or a type of your rectilinear motion. May kinalaman siya sa force and your center of gravity. Diba, the force has 3 characteristics. What are the 3 characteristics of force? Kanotag. From our midterm topics. Saan siya? Hindi nyo alam, sabihin nyo. Para hindi tayo nagtatagal.
Strong force.
Characteristics of force. Okay, Mr. Javier.
Sir, weak force, gravity, and electromagnetism.
No. Masyado namang ano yun. Masyado nang complex yun. Characteristics of force. Tatlo yun. Enumerate ko siya sa Introduction to Forces. If pinanood nyo yung video, you should have an idea of it. Okay? I guess no one knows the 3 characteristics of forces. That is part of your physics. And I believe you should already know that. So the first one would be the magnitude of the force. Right? Since it is a vector quantity, it is composed of magnitude and direction. And in that case, yung second characteristic of the force is your direction, or what we also call the sense of the motion, or of the force. Sense of the force is the direction. So the first characteristic is the magnitude of the force. It determines how big or how small is the applied force. The next one would be the direction or sense of the force. And the third one is the line of action of our force. So, basically, we are producing rectilinear motion based on the 3 characteristics of our force with respect to its center of gravity. Okay, let me find something. Okay, kunwari itong phone ko. Let's say we have this object and the center of gravity is at this point. Can you follow? Kunwari yan yung center of gravity.
Yes, sir.
Okay? If the force will act on the center of gravity, using the principle of transmissibility also, syempre hindi naman siya diretso dun sa may gitna, di ba? It will act here. But it will pass the center of gravity. Naturally, the line of action will also pass the center of gravity. Because that is the direction of your force. Yung line of action natin is always collinear with the direction of your force. So, if that is the point of the center of gravity, and you are having this force pushing it to the left, yung line of action will be collinear with the center of gravity. Pag sinabing collinear, it will pass through that common point. It will pass through the point. Okay? If the direction of the force is not changing, meaning constant yung direction ng force natin, we will produce rectilinear translation or rectilinear motion. Okay? Kapag constant yung direction niya, pag hindi nagbabago. Rectilinear motion, straight yung path niya. If in the case naman that you are changing the direction of your force, for example, nagmo-move siya na ganyan, then it will follow the body will be in curvilinear motion na. If it is changing in direction, magku-curve yung path niya. So, since we are not changing the direction of our force, when we are applying it on the center of gravity, or collinear with the center of gravity, then that would be rectilinear translation. Basically, a review of your midterm topics and your physics na rin. Okay? Can you follow? Do you have questions so far? None? Okay. Let's continue. So this is the first case of our rectilinear motion. Constant velocity. This is the position time graph. Your S is the position and your T is the time considered. So your velocity is equal to the change in the position with respect to time. And that is equal to the slope of this line. Okay? From position to velocity, we will differentiate. Ba? To differentiate it, na, the curve will look like this. You have your velocity in the y-axis and your time at the x-axis. So you have your, from this one, from the position time curve, you arrive with your velocity time curve. Which makes sense kasi nga constant yung velocity. So, hindi nagbabago yung value ng velocity natin. Okay? Reference dito is 0, 0, the origin. So, the vertical component will have a value. Hindi siya 0. Meaning, there is velocity. Okay? That is acceleration. The derivative of the velocity with respect to time, and that is equal to the slope of this line. Slope of the velocity time graph. If you will further differentiate this, ano ang derivative ng constant value? What is the derivative of a constant value? Miss Lictao?
0, sir.
0, correct. From your differential calculus. Ang derivative ng constant is always 0. So if you will take the derivative of this one, this curve, you will arrive with the acceleration time. Kasi nga, di ba, from position velocity to acceleration, you are doing differentiation. Kanina, dito. From this one, position to velocity to acceleration, we are doing differentiation. So, continuing. Wala. Okay. So we will take the derivative of the velocity time graph. that is constant. So, that would be equal to 0. You will notice dun siya, nag-coincide siya, or naging collinear siya dun sa may time axis natin. Because there is no acceleration, or there is constant velocity. Okay? And, if you are going to characterize the change in acceleration with respect to time, that is called the jerk. The change in acceleration over a time interval. So, yan yung bago na narinig natin. Jerk, the change in acceleration. Since there is no acceleration, naturally, the jerk will also be 0. Constant pa rin naman yung 0, so the derivative of a constant is still 0. Derivative of 0 is 0. So for the next type of your rectilinear motion, you have your constant acceleration. You have your position time graph. Same thing. For your velocity, that is equal to the derivative of your position with respect to time. This time naman, the degree of this curve is equal to 2. If you will differentiate to obtain the velocity time curve, you will arrive with a first degree line. Okay, differentiation to. And to take the acceleration, you differentiate further, you will arrive with the constant acceleration. And if you will take the jerk or the change in acceleration, that will just be equal to 0. Okay? The last type of rectilinear motion, your motion with variable acceleration. We have your position time curve. The velocity is equal to the derivative of the position with respect to time. Then if you will differentiate that one, you will arrive with, by the way, this is a third degree curve. If you will take the velocity time curve, this will be a second degree curve. So pag differentiation, we are decreasing the degree or the curvature of our line, or of our curve rather. So if you will differentiate this, you will arrive with motion with variable acceleration. This variable yung acceleration niya, you will have a value for the jerk. Is it clear? Okay. So now move to the area method to establish motion diagrams. We have here your acceleration time. For the area method, we are going to use integration for this part to find rather the curve of our velocity and position time curve. We will consider here a curve of an acceleration with respect to its time. This is your initial acceleration and final acceleration. From the reference time, or from the time being considered to the final time, your difference would be Tn minus T0, and you have your slope equal to the jerk. Ganun lang din, pabaliktad naman. If you will consider A, given the AT diagram or the acceleration time diagram, A is equal to dv over dt, or the slope of velocity time. A is given, therefore it is constant. Acceleration is equal to the change in velocity with respect to time. If you will manipulate this, cross multiply dt to the other side of your equation, you will arrive with dv is equal to a dt. And if you will take the integral of both sides of your equation, the left part would be from initial velocity to the velocity you are considering, and from the initial time to the final time, which makes sense dito. From original time to final time, it will have a velocity and final velocity. So, applying integration, you will arrive with this equation. Vn minus V0 is equal to A times T n minus T O. Okay. Your Vn minus V sub O is equal to the area of your AT diagram from Tn to T0. So this one, from our acceleration time diagram, the area of this portion is equal to the change in the value of the velocity of our inner velocity time curve. We will demonstrate this using an example later on. These are just foundational concepts. Applying the same method for the velocity, you will arrive with Sn minus So is equal to velocity times Tn minus T0, and that is equal to the area of the Vt diagram from T sub n to T sub 0. Again, we will demonstrate this later using an example. And here is our first example for the area method to establish the motion diagram. We are given this curve. That is the acceleration and time graph. And we are asked to plot the velocity time and position time diagram. To do that, we will use area method. And the concept behind area method is, of course, your integration. You have your condition at time is equal to 0. Based on your graph, this is your time equal to 0. The velocity is equal to 0. And the position is also at 0. So these are important because it will determine what is our starting point when we draw the diagram of our velocity time and position time. So the solution here would be the area of this part, that is a trapezoid. Let us divide it into the rectangle and the triangular part. The area of the rectangular part would be, that is 4. Unit is meters per second squared. And the time interval is 2. From 0 to 2, right? From your formula a while ago. Area is equal to, or Vn minus V0 is equal to acceleration times the change in the time. So using that, we can look for the change in velocity. This area is representing the change in velocity. Similarly, in the triangle, the area is 1/2 times base times height. Your height is still 4 meters per second squared, and the base will of course be the interval, not 4, because we are talking about the change. So 4 minus 2 is 2 seconds, and that will have an area of 4 meters per second. Continuing, using that solution, we will arrive with your velocity time diagram. We have a condition a while ago that your velocity when time is 0 is also equal to 0. So, if you will notice here in our velocity time graph, we started at 0.0 because the area is just talking about the change. The area here is the change, not the absolute value. So, from our initial velocity of 0, the change in the velocity, that is at the positive plane, positive yan. Kapag nasa ilalim, that should be negative. But that is positive, so there is a positive change, meaning we have increased our velocity. So, from 0, we added 8 meters per second. So, if you will notice, the endpoint there is at the 8 meters per second velocity. So, that is the change. Notice also that we are increasing the degree of our curve because we are integrating. Okay, and then next, remember that this area, the areas here, are referring to the changes. So we will not start with 0 again. We will start dun sa 8. We will just add the value of the area. So if you will add that one, start tayo sa 8 meters per second, we will add an area after 4 seconds, ang area nito ay 4 meters per second. So we will add 4 meters. So from 8 plus 4, that is 12 meters per second. And notice we are also adding the degree of our curvature. How do we know yung slope niya? Later on, we will demonstrate that. Okay. Applying the similar concept or similar method, we can solve for the area of these parts, which is a triangle, a rectangle, and a parabola. I believe you already know the area of the parabola. That is 2/3 of base times height. So the area here is referring to the change in the position. So that is 8 from 0. Yung again, the condition a while ago is that when time is 0, the position is also at 0. So we will start at 0. And that is in the positive plane. So we will increase your position by 8 meters. So if you notice here, the height here is 8. And then again, we will add, since the area is referring to the changes, 16/3 plus 16, we will arrive with a height of 29.33. So reviewing some concepts, if you will have your position, velocity, and acceleration, you can obtain each of these equations using integration and differentiation of your values. Let's try to have an example. Let me just change my screen. Do you have questions so far? Yeah. Let's continue. Can you see it clearly or malabo?
Malabo.
Yan. Okay. So let's continue. Again, if you have your position, velocity, and acceleration, from position to velocity, and from velocity to acceleration, anong process yung ginagawa natin? That is differentiation. If, for example, you have your acceleration equation, you want to look for the velocity equation and position equation, you will use the opposite, and that would be integration. Okay? So let's try to demonstrate it. For example number 1. We are given the position equation in terms of time. Para t raised to 3 minus t 2t squared. This is the position equation. To find the velocity and acceleration equation, ang required natin, we are asked to find velocity as a function of time and acceleration as a function of time. We will just differentiate. Take the derivative with respect to time. The derivative of the position with respect to time is equal to, what is this equal to? Change in velocity or in position. Yan. Sino si Lucy Bear? Lucy Bear. Sino si Lucy Bear? Palitan niyo yung pangalan niyo ng totoong pangalan niyo.
Mga gaming names.
Gaming names ba? Alam ko pwede nyo namang palitan yan for the specific, we call this, group. Ayun. Pwede palitan. Anyway, sino nakakaalam? What is the derivative of s with respect to t? Change in position with respect to time.
3t squared minus 4t.
Excited? Wag muna yung differential. Ano muna yung ds over dt?
Velocity.
That is equal to the velocity. Okay? That is your velocity. And this is equal to, applying differential calculus, 3t squared minus 4t. So we have your velocity equation. And the derivative of the velocity with respect to time is equal to the acceleration now. Right? Yes, Joshua. Okay. So, applying differential calculus again, this is equal to 60 minus 4. There you have it. You have your velocity and your acceleration using the process of differentiation of your formulas or your equation. Second example. What if you are given the acceleration equation? How about this one? And you are looking for the velocity in terms of time and the position in terms of time. So, what we're going to do here, simplify muna natin yung equation. Binomial expansion, this would be 3t squared negative 3. Distribute negative t. This is negative t raised to 3. And then, distribute negative t. This will be positive t. Okay? Alam niyo naman na yan. And again, acceleration is equal to the derivative of v with respect to time. Let's copy it here. 3t squared. O unahin natin yung mataas na degree. Negative t cubed plus 3t squared plus t minus 3. Cross multiply dt to the other side, you will have dv is equal to negative t raised to 3 plus 3t squared plus t minus 3. Derivative of t. Integrate. We have here your velocity is equal to ang integral niyan. Ano yung power formula ng integral natin? The integral of x raised to n dx, that is equal to x raised to n plus 1, right? Divided by n plus 1. Okay, applying that one, we will have factor out natin yung negative and then apply the power formula here. This is t raised to 4 divided by 4 plus factor out yung 3. This is t raised to 3 divided by 3 plus t squared over 2 minus 3t plus the constant. Pero kaya muna natin yun. And then we will have your velocity simplifying negative t raised to 4 over 4 plus t raised to 3 plus t squared over 2 minus 3t. And again, your velocity is equal to derivative of position with respect to time. Applying the same process, you will arrive with ds is equal to negative 1/4 t raised to 4 plus t raised to 3 plus 1/2 t raised to 2 minus 3t. Multiply this by dt. So, taking the integral, indefinite integral tayo, this is equal to s equal to factor out the constant. This would be negative 1/4. Integrating t raised to 5 divided by 5 plus t raised to 4 divided by 4 plus 1/2 t raised to 3 divided by 3 minus 3t squared divided by 2 plus the constant of integration. Lagay nga natin yung constant of integration para hindi naman confusing. We have here plus a constant of integration times t. Then, simplifying, you now have your position equation. And that is equal to negative t raised to 5 over 20 plus t raised to 4 over 4 plus t raised to 3 over 6 minus 3 halves of t raised to 2 plus the constant of integration times t. Isabuan natin to. Add the second constant of integration. Okay? That is how you use differentiation to find the equation of your velocity and acceleration and position in terms of time. Can you follow? Let's have this one. You have your acceleration time curve this time we will be using area method. And we are looking for the velocity time diagram and also the position time diagram. Okay, so this time we will have a condition that time is equal to 0, the velocity is equal to 2 meters per second, and the position is equal to 1 meter. Okay, so continuing, let me have a grid line para may guide tayo. Okay, so we will proceed with hirap mag-drawing sa screen. Bear with me. challenging yun. So, we will have, this is your time position. 1, 2, 3, and 4 para sa ating x-axis. You will have your velocity here. Velocity is in meters per second. And this would be elements of 2 na lang. We have a different scale for the x and y axis. It is shown by this scale numbers. Okay. Let me copy this one para hindi natin gawin later. Copy it sa here. Para sa ating acceleration diagram later on. So we have velocity time graph. And our condition says that at time is equal to 0, we have your velocity at 2 meters per second. O kunwari gawin natin negative para may challenge. Ayaw gusto ng aking nawala yung ballpen ko. Okay. So, we have a condition here. At time is equal to 0, we have your velocity equal to negative 2 meters per second. So, our starting point would be negative 2. Kasi yung condition natin, at time is equal to 0, This is your time equal to 0. Your velocity is negative 2 meters per second. So we will start here. Okay? And we have your area of the rectangle. The area again defines the change in the value of your velocity. So it increased by positive 8 meters per second. So from negative 2, it will increase by positive 8 plus 2 plus 4 plus 6 plus 8. Right? So the end point should be here after 2 seconds. Right? Because this is ending at 2 seconds. Negative 2 plus 8 positive increase is equal to positive 6. Okay, can you follow? So, the degree of our first curve is 0. So, that is increasing. Constant increase. Okay? Positive constant increase. We will look at the initial value of your acceleration is equal to the initial or final acceleration. So, nag-i-increase siya constantly. So, this will have mali. Now, let me just look at the drawing.
Rated na kanya kasi. Ayan, try natin sa Facebook.
Okay, so this is our line.
Sabali mo yung katawanan.
Then again, we have increased by 4 meters per second. So this is our starting point now. Increasing it by 4, we will have here 12. Increase by 4. But the 12. It should be 10. 10 meters per second. So after 2 seconds again, this would be, the ending will be here. 4 seconds, 10 meter per second velocity. So for the curvature, since we started with a degree of first degree, we will increase it by 1. So the curvature of this curve will now be second degree. So it is now a second degree curve. Now for this one, if you will notice here, that is positive, so that is going up. If this is in the horizontal if this area is below, meaning that is going down. Okay? Can you follow? Naintindihan niyo pa ba ako? But since that is in the positive plane, so pataas tayo. We will go up. Later, ito demonstrate natin. So, For this one, we will have the absolute value of this, the starting point is greater than the ending point. Okay, this is 0. Ibig sabihin, the slope will be decreasing. You have here for the slope. Sabi ko sa inyo kanina, the absolute value of the starting point here is greater than the absolute value of your ending point in the area. So, from greater to lower. Let's review yung concept ng ating slope. We have 4 types of slope, right? For this one, yung vertical, horizontal. Yan. These are basically the 4 types of your slope. For the first line, what is a vertical line? What is the slope of that line? Anyone? Differential calculus. Ano ang slope ng vertical line? Hindi nyo na maalala?
Undefined, sir?
Undefined or infinity.
Atlantis.
Ang slope niya ay infinity. Okay? Kasi yung rise over run, di ba? Slope is equal to the rise over run. Yung rise niya is infinity for a value kung it is not a continuous line divided by the run is 0. So, any number divided by 0 is undefined or infinity in that case. So, slope ng vertical line is infinity. Slope naman ng ating horizontal line is 0. So, slope nito, infinity. Slope ng horizontal line is 0. The slope of this line going increasing line, ang slope nito ay is that positive or negative value?
Positive value.
Positive value. The other one, slope niya ay negative value. Okay, so using that one, ibig sabihin, mas mataas yung if this positive slope will increase its slope, it will achieve yung infinity. So, mag-increase siya up to infinity. So, this slope is greater than the slope of this second line. Tama ba? Tama. Greater slope and lower slope. And the absolute value of the starting line or the starting and the ending of your curve will dictate the slope of your velocity and time. So, greater yung absolute value niya, 0 to, so lower yung absolute value nito. Tama ba? So, ang slope natin, gamit tayo ng ibang line, is from a greater slope to a lower slope. Tama ba? Greater absolute value and lower absolute value. It should be 0 pala. Tama. Can you follow? Okay, so ibig sabihin, the curve will follow those tangent lines. And it will look like this. That is your endpoint. Ang height niya ay 10 meter per second. Meanwhile here, ang height niya ay 6 meters per second. Okay? I hope that's clear. Let's now continue by finding the areas of this lipat natin siya dito. Divide natin into 4 areas. The smaller triangle, the larger triangle, the rectangle, and the parabolic segment. Try natin lagyan ng colors. And finally, yung last area natin, yung parabolic segment, gawin natin blue. Okay. So the first area, that is a triangle. So ang area niya ay 1/2 distance height, right? Guys, ang hindi pa ba yung area ng triangle? Yung height natin is -2, but we do not know the base. And to know the base, we will use ratio and proportion by similar triangles. Naalala niyo pa ba yun? Hindi na rin. So, let me transfer this one. So, sa baba. Okay. Let's go back. For the first area, kailangan natin yung this distance. So, to find this, divide natin siya into 2 segments. Let's name this x, and this is 2 minus x. Because that is 2 seconds from the origin, right? Okay, using ratio and proportion, the height of this value is 2. Absolute value tayo kasi yung magnitude lang naman ang kailangan natin. And this would be equal to 6. Right? 6 ang height niya. This angle is equal to the other angle. That is theta. This is also theta. So using similar triangles, you can draw your smaller triangle here. And the bigger one. If this is theta, this is also theta. Opposite the theta is 2. So this is 2. Adjacent it is x. This would be x. Opposite the angle theta is 6. And the adjacent to that angle theta for the bigger triangle would be 2 minus x. Can you follow? So using ratio and proportion, 6 is to 2 for similar triangle, yun yung concept ng ratio and proportion. 6 is to 2 and 2 minus x is to x. Plus multiply, you have 6x. This is equal to 4 minus 2x. And then 6x here, transpose to the other side, yung negative 2x, magiging positive 2x is equal to 4. 4. Huwag ka maniwala sa sinuot ko. So, yan. Okay? Adding these two together, you have 8x. This is equal to 4. Your x is equal to 1/2. And its unit is seconds. So now that we know the value of x, this distance, we can solve for the area of 1 or area sub 1. Area sub 1 is just equal to 1/2 base times height. Your base is 1/2 seconds. And the height is negative 2 meter per second. Tama ba? So that is area sub 1. And that would be equal to negative 1/2 meters because the second will cancel. Tama ba? Can you follow, guys? Okay, that is area sub 1. Area sub 2, that is also 1/2 of the base. The base here is 2 minus x. 2 minus x, which is 1/2, is equal to 1.5. 1 and 1/2 in mixed fraction or in proper fraction, ano to? 3/2 of a second. So the base is 3/2 of a second. The height is positive 6 meters per second. The second will cancel. Leaving you with meters. Area sub 2 now is equal to, what is that? 6 times 3 is 18 divided by 4. 9/2. Can you still follow? 9/2 of a meter. So yan yung changes. Negative dito, positive dito, other one. For area sub 3, this is equal to a rectangle equal to base times height. Your base is 2 seconds. And the height is 6 meters per second. Positive. So this is just equal to 6 times 2 is 12 meters. Area sub 4 is now equal to a segment of a parabola. And that is just 2/3 of base times height. 2/3 of base times height from your calculus. If you are considering this one, this segment, that is 2/3. But if you're considering the other part of your parabola, then that would be 1/3. Okay? Recall nyo yung properties ng parabola. So this would be equal to 2/3. The base would be positive 2 seconds. And the height is the difference between these two velocities. 10 minus 6 is 4. So that would be 4 meters per second. This now will be equal to 16 divided by 3. Area sub 4 is equal to positive 16 over 3 meters. It's also positive. We are now ready to plot the acceleration curve. This is acceleration. I think we need to Can you hear me properly?
Yes, sir.
Muulan kasi dito. This is our position. S in meters. I'll just change the scale of our vertical axis para magkaka sila. Let's make this 4, 8, 12, 16, 20, 24, 28. Okay, let's continue. Let's go back to the condition that at time 0, the position is at 1 meters or 1 meter. So we will start at 1 meter. Hindi pala naka-sakto. I'll just adjust. Okay. So we will start at this position. This is 1. That is the condition. And your area 1 will increase by or decrease by negative 1/2. And we will end at time equal to 1/2 seconds. So if this is 2, this is 1, this is 1/2. It should end at, we will decrease it by 1/2. So we already laid your endpoint. Next thing to do is your curvature. You will notice here, this is decreasing because it is below the time axis. So, kaya tayo nagbaba. We went down. Kanina, we went up because that is in the positive axis. So, positive yung changes. It is also reflected here at the value of the change in area as the change in position. Negative siya, so bababa. Negative, so the slope will be, absolute value here is greater than going to a lesser absolute value or zero absolute value. So, yung slope natin is decreasing. So, gawin kong malaking scale dito sa kabila. So, you can see it properly. This is 1/2 second. And this would be 1. This is your S. Starting point is at 1. We will end at this here. Because 1 minus 1/2 is negative 1/2 or positive 1/2. Positive 1/2 meters. Can you follow? Yan yung endpoint natin. And for your slope, let us again use another color. A greater slope and zero slope. Okay? So, the concavity will look like this. That one. That is your first drawing. And then, for the second curve, we will start at positive 1/2 and then we will add 9/2. That would be 0.5 plus 9/2 is 5. So we will end at 5. ito yung 5. This one. So if you will notice, the absolute value is 0 to a greater absolute value, increasing, going up siya kasi positive yung area 2 natin. So meaning, it will increase its slope. From a 0 slope, it will increase its slope. So, parang ditong part na to, yan yung slope niya, and then you will have your let's just say na tangent siya dyan. O ilipat natin para medyo clear. Let's draw first the curve. And this is your tangent line, representing the change in your slopes. So, this will look like this one. Tama ba? No, it ends at 2. So, medyo i-extend natin dito. It should be here. So, 0 slope to a higher slope. Okay? And then, we will add the areas 3 and 4 because that is belonging to the same region. Area 1 or area 3 plus area 4 is equal to 12, positive 12 plus 16 over 3. This would be equal to 52 over 3 or 17.33 positive. So our reference is at 5 here, and then we will add 17.33. So 5 plus 17.33, this is equal to 22.33. So we will end at 22.33 at time equal to 4, and that would be here. For the concavity, the absolute value is increasing. Lower absolute value, and it increases its absolute value. So the slope will also increase. If this is your original slope, it should increase. So parang will follow that slope. It increased its slope because it increased in the absolute value from the start of the region to the end of the region. So this would be looking something like this. So the height of this one would be 22.33 meters. This one should be 5 meters. And this one is 1/2 of a meter. So we now have your position time diagram. And if you will notice again, the degree of this line will increase. Ang degree nito ay 1. So from the first degree, this became second degree. This is also first degree. And for the position curve, yung degree nito ay second degree and the degree of third region would be third degree. This one also will be a second degree curve. So from your acceleration time diagram, we have obtained your velocity time diagram and your position time diagram. Do you have questions? Guys, do you have questions?
Answer.
Wala na? Okay. So, that will be all for today. We will continue our discussion next meeting. I'll announce na lang kung mag-discord tayo or I'll give an asynchronous activity. Any other concerns regarding sa class natin?